So if you've never seen the head to a car, it's pretty interesting, but also simple. This piece here it sits on top of the cylinders. Your pistons are coming up and down right here on these valves. And then there's a camshaft on this side. So if we flip this over, we'll see the camshafts, and those have cams on them. And what that does is it moves the valves up and down in time with the engine. So say we have one of the pistons coming down right here. Of course, all this would be inverted and the piston would be coming up. So it would come down like this. If all the valves are closed, then it's going to build compression because it's such a good fit in the cylinder that it creates compression. And that's called the compression stroke. And whenever it comes back out, that can be the exhaust stroke or the intake stroke or the power stroke. So say the piston now is coming in, and then as it comes back out, these are the intake valves. The intake valves will open as the piston is coming up and let an air-fuel mixture come in. So it'll suck in the air-fuel mixture. So this is a ratio of air to fuel. It's the perfect ratio where it will burn efficiently. Then those valves will close. It will compress that mixture, so it'll be under a lot of pressure. And then this is where the spark plug goes. And then the spark plug will make it spark. And what that does is ignites that air-fuel mixture. And under its compression, it ignites and expands, which throws the piston back. That's the combustion. And then this is the power stroke, whenever that gives it its power. And then when it comes back around, these exhaust valves open, and then it pushes all that exhaust out. They close, and then the intake valves open again and let in the air-fuel mixture again. So that is happening on all 4 cylinders very fast. So it's going in the firing order. So let's flip this over and see the cams. So over on this side here, these are all of our cams. And each one of these cams controls a different valve. So this cam will control a valve over here. So that one will, it's hard to see, but it's the valve right here. That will move up and down. So all of these cams are also in time. That's what this chain here is. These are connected by gears. So when this spins, all of the gears will spin in time with the valves. And then this is a pulley right here, a timed pulley. And then this connects down to another part of the engine. That's the actual drive for the cylinders. And all of this connected with a belt. And then this belt keeps the engine in time, and it's called timing belt. So what happened on this engine was that timing belt broke. And then this, and the drive down here, the pistons were still moving up and down whenever this stopped moving. And so then it just gets out of time. And if you can imagine, if your engine gets out of time, the valves are moving up and down at a different speed than what the cylinders are doing. So if your intake valves are open and your cylinder comes down while these are fully open, you can imagine what's going to happen. The piston is going to hit those valves and bend them. So that's what happened to this engine. You can see some of these valves are bent, and I can even see little dents in the valves where the piston hit. So that's what happens when the engine went out of time, and that's always a reason why you want to replace your timing belt so that doesn't happen. These right here are the cylinders in the engine. So these are all of your pistons. Now here is a bent valve from another engine, and you can see how this is not straight. This should be straight, and if you look close enough at these pistons, you can see that valve hit right there on the piston and actually scored it. So this is whenever this valve came down, this came up and just whacked it really hard. This happened whenever we were going at about 60 miles an hour on the highway when that snapped, and then the valve, it just came up at such a high speed, it just bam, that piston hit it really hard and made those indents in the cylinders. So if I crank this is the wheel right here, the timing gear. On these valves back here, if I move this, you can see those go up and down. So that's what I mean whenever they get fully extended. And also, it does get a little bit hard to turn right now. I can't turn it all the way around because of these valves here. They're bent and then they're causing pressure, so it makes it harder to turn. But these valves here are now fully closed. And now these are starting to open as far as I can go in that direction. And now those close. See how these are starting to open here, and then those start to open. So all those cams are going in times. When you spin this, you would see the valves go up and down in that order. So basically what these cams are doing is they're pushing right here on the valve. It pushes it up, then it comes back up, pushes it down, comes back up. Now it's not pushing directly on the valve. If you look in here, these pieces here, those are called lifters. And then that pushes down on the spring, which is connected to the valve. Now if I twist this, of course it's a little, there you go. You can see those cams moving, and then those push down the lifters, and then that moves the valves. So on this side of the engine, this is where the exhaust manifold would bolt on, and then this connects to your exhaust pipe, which goes out the back of your car. If you look in here, you can see the actual valve. What the part you're seeing is this part here, and then that's pushing up against the cylinder. So that in there is the valve. So this is where the exhaust will be pushed out. Whenever that piston comes down, or comes back up, it will push the exhaust out. And then on the other side, it's a very similar thing, except this is where it sucks in the intake. So then when the piston comes up, it creates vacuum, so it sucks the intake in from here. So that's just a basic explanation on how the head of a car works. So I hope you guys found this video useful. If you did, don't forget to like and subscribe, and we'll see you next time.